Alright, so this video will continue to cover factoring. The method that we're going to use today has two names, and it's helpful to know both names because it pretty much gives you the steps that you're going to be using to solve by factoring this way. So the first name is AC method. That's going to be the first step in this process. And then the other name is called grouping. So we are still factoring. We're factoring using the AC method, and we are factoring by grouping. So let's go ahead and get started. Okay, so here are our steps to solving by factoring. So the first step is we are going to multiply A times C. So that's why we call this AC method, because we start off by multiplying A times C. So we're going to use negative 15, the number I just got, by multiplying the coefficient of p squared and the constant negative 5. We're going to use that to come up with two numbers that multiply to be negative 15, and then they also need to add up to negative 2, to our middle value, negative 2. So what multiplies to be negative 15 and adds to be negative 2? That's negative 5 and positive 3. Negative 5 times 3 is negative 15. Negative 5 plus 3 is negative 2. So what we're going to do is we're going to rewrite our middle term, negative 2p, as negative 5p plus 3p. So we're using the two numbers that we just found, and that is equivalent to negative 2p. So I'm not changing my equation, I'm just breaking it apart. And so that gives me 3p squared minus 5p plus 3p minus 5 equals 0. So I'm just taking my original problem and rewriting it using my two numbers. Okay, so now the other name we call this is grouping, because we're going to make two groups. We're going to make a group with the first two numbers and a group with the second two numbers. And so we're going to see what is the GCF of each group. So the GCF of this first group, 3p squared and 5p, the greatest common factor is p. They both have a factor of p. So I'm going to factor p out, and what I'm left with is 3p minus 5. Because, again, if, as in our last video, we could redistribute this. 3p times p is 3p squared. 3p times negative 5 is negative 5p. And then we're going to look at our second group. What is the GCF of 3p minus 5? Well, there isn't anything that they both have in common, so if two things don't have a GCF, they have a greatest common factor of 1. So my GCF of the second group is 1, and I'm left with 3p minus 5. So to put this in factored form, I'm going to take the two GCFs, p and 1, and put them together. So p plus 1 is one factor. And then my other factor is going to be the binomial that I was left with from both groups, 3p minus 5, which is equal to 0. So since both of these are equal to 0, we can use the zero product property to say either p plus 1 equals 0 or 3p minus 5 equals 0. And so I get my two answers are negative 1, p equals, whoops, let's erase that, p equals negative 1, or p equals 5/3. This is another way. We had 3p squared minus 2p minus 5. And essentially what we did is we undid box method. By finding those two numbers, by finding negative 5 and 3, we were able to essentially get box method, get the four terms that we would have had in box method. And what we did is we saw, okay, well, of 3p squared and 5p, there was a GCF of p, and of 3p and negative 5, there was a GCF of 1, which left us with 3p and negative 5 as my other factor, because p times 3p would be 3p squared, p times negative 5 would be negative 5p, 1 times 3p was 3p, 1 times negative 5 was negative 5. So what AC method allows us to do is it allows us to essentially undo box method to figure out what were our two factors that we would multiply to be left with this trinomial. So anytime we're factoring, the first thing that we want to do is we want to divide by a common factor if possible. Because right now, if I had to multiply A times C, I would not be very happy because 25 times 60 is going to be a pretty big number. What I notice though is all three terms are divisible by 5. So I can start this process off by dividing everything by 5. That's going to give me 5x squared plus 19x plus 12 equals 0. This just makes the numbers a little bit easier to deal with. Okay, so let's follow our steps. Step 1 is to multiply A times C. So 5 times 12 is 60. So I'm looking for what multiplies to be 60, and then it has to add to be my B term. And so the two numbers that work there are 15 and 4. 15 times 4 is 60, 15 plus 4 is 19. So once I come up with these two numbers, I'm going to rewrite my middle term as 15x plus 4x. So that's going to give me 5x squared plus 15x plus 4x plus 12 equals 0. So now I get into the grouping part where I want to find the GCF of both groups. So the GCF of the first group, they both have a 5 in common and an x. So I'm going to take the 5x out of both terms. Oops. 5x. And what I'm left with is x plus 3. Then I'm going to look and see what is the GCF of my second group. They both have a common factor of 4. And again, I'm left with x plus 3. If you do this right, you're going to be left with the same binomial each time you factor out the GCF. So my answer, or my factored form rather, is 5x plus 4. And the remaining factor of x plus 3. And so since that's equal to 0, we can use the zero product property to say 5x plus 4 equals 0, or x plus 3 equals 0. So my answers are negative 4/5 and negative 3. So since we are using the zero product property, it's really important that we make sure our equation is equal to 0. So here we need to move 9 to the other side, and so that's going to give us 2n squared plus 3n minus 9 equals 0. So now we're going to use AC method to do A times C. So I'm looking for two numbers that are going to multiply to be negative 18, A times C, and then they have to add to be 3. So since it's going to be a negative 18, I know one number has to be negative and the other has to be positive. So let's see. 6 times negative 3 is going to be negative 18, and 6 plus 3 plus negative 3 is going to add to be positive 3. So I'm going to take and break up 3n to give me 2n squared plus 6n minus 3n minus 9. And now we're going to factor by grouping by making our two groups and finding the GCF of each of them. So the GCF of the first one is 2n. And when I take 2n out, I'm left with n plus 3. And so I can kind of, as I'm learning the steps, I can kind of cheat. I know the binomial I need to be left with has to be n plus 3. So that helps me see that my GCF here from negative 3n minus 9 has to be negative 3 so that I can be left with n plus 3 as my binomial from that group. So 2n minus 3 is my first factor, and my second factor is n plus 3. And since I made sure at the beginning to make sure my equation was 0, I can use the zero product property to say that 2n minus 3 equals 0, and n plus 3 had to equal 0 as well. So n was 3/2, and n was negative 3. So those were my two answers. So let's try this problem, solving for x. Make sure you divide by a common factor if possible, and you make sure the equation equals 0. So here are the steps to solving for this one. I divided by 3. I added 5 to both sides, and then I did AC method. Sometimes when you're having trouble finding the two numbers, I always like to tell myself it's the easiest 1. It's always the one with the number in itself, so with 1 in itself. So that's a strategy to knowing what the factors are. And so my answers I got were negative 1/2 and negative 5.